Hello, algebra students. Mr. Lawrence here, and this video is going to be really quick. It's for Kelsey because she was asking about systems of equations in terms like inconsistent and independent and that. Okay, now remember, when we solve a system of equations, we're attempting to find a place where the equations intersect each other. If we graph them, they're usually linear equations in Algebra 1, but they don't have to be. They could be quadratics, etc. All right, and there's going to be three possibilities, okay? When we graph, and I'm not going to solve by graphing, but I'm going to show you how to interpret the algebra. We might get two lines that intersect at a specific point. And that's pretty easy. That's usually what we do. You know, we use elimination or substitution, and we find the coordinates of the place where they cross. Then again, we might get two lines that are parallel, right? So there'd be no solution to it. And in some occasions, we can get the same exact line twice, right? Okay, well, these have special terms. Okay, when here there's one solution, right? And since there is a solution, we call this a consistent system. Consistent. Okay, because there is a solution, it's consistent. All right, and we also say that it's independent, meaning the two equations are independent of each other. They're free of each other. They don't have anything in common except that they cross at that one point. Otherwise, they act independently. This one here is going up to the right. It has a positive slope. The one here is going down to the right. It has a negative slope. The only thing they have in common. So this is kind of like consistent. There is a solution, independent. They don't rely on each other, kind of like we broke away from England to become independent, right? We had that common history up until we break away. All right, so in this situation, these lines are parallel, so there is no solutions. No solution. And this does not have any solution, so we call it an inconsistent system. It's inconsistent because the lines will never cross in flatland, okay? In two-dimensional geometry. So it's inconsistent. I'm not sure what I just spelled there. Sorry about that. I'm thinking too much as I write. Inconsistent. That looks a little bit better. All right, excuse me. So a parallel set is no solution, and it's an inconsistent system because there is no solution. Now, this one here, the two lines, you can't see the red line, but I put the red arrowheads on it. The two lines are intersecting everywhere, right? So this has infinitely many solutions. And since there are solutions, this is consistent. But since all the points are on both lines at the same time, we call this a dependent system. Dependent. Okay? So when it's the same line twice, we're going to get a situation where it's infinitely many solutions. That means it's a consistent dependent solution. Now, when you solve these different ones, this one here, you're going to get a point, the black one, you get a point like 3, -2, or maybe you'll get a point like 5, -6. Now, when you go to solve the green one, what's going to happen is you're going to get a false statement like 7 equals 10. 7 never equals 10, so these lines will never cross each other. When you go to do the blue one, you're going to end up in a situation where something is always true, like 2 equals 2. When does 2 equal 2? Always. It always equals 2, so therefore there's an infinite number of solutions. So what I have for you here are three systems of equations, and we're going to go through and solve them and by any method you want. I'm not going to graph them, but you could if you wanted to. And when I do that, we're going to see what we end up with. So this one here looks like a great substitution problem. It would be a good graphing problem, but I'm going to do it by substitution. I'm going to let 2x plus 5 substitute in for the y in the green equation. So I'm going to get 2x plus 5, and that's going to equal 4x minus 7. I don't like the fact that there are x's on both sides of the equation, so I'm going to subtract 2x from both sides. And since my x's are going to be over here on the right, I think I'm going to add 7 to both sides at the same time. And when I do that, I'm going to end up with a 12 equals 2x, and x is going to equal 6. Now I'm not done because now I have to solve for y. Now it shouldn't matter which equation I use, but I'm going to put 6 in for x. So 6 times 2 is 12, plus 5 is 17. So y is 17. So these two lines will cross at the point 6, 17. If I want to check it, I could go 6 times 24, or 6 times 4 is 24, minus 7, and I will get 17. So this is a consistent and independent solution. Independent, right? There you go. Consistent, independent, one solution. Okay, let's try this blue one. It also looks like a good substitution problem, so I'm going to substitute this in for y. So I'm going to get 4x minus 6 times the quantity of 2/3 x plus 1, and that's supposed to equal 8. All right, so I'm going to distribute that negative 6. Now let's see, 3 is going to go there twice. It looks like it's going to be a negative 4x, and then a minus 6, and that equals 8, because remember, I had to distribute. I had to pass out candy to everybody in the row. All right, and so when I do that, these are going to cancel out, right, the 4x's. So I'm going to get negative 6 equals 8. Well, when does negative 6 equal 8? It doesn't. It never equals 8. These lines must be parallel. In fact, if I go check the slope, the blue slope is definitely 2/3. And the slope of the black one is negative a over b. It's negative 4 over negative 6, which simplifies to 2/3. So you see they are parallel. So this has no solution. The two lines never cross. And it would be an inconsistent system. Inconsistent because the two never cross. All right. So the last one here looks like I think I'm going to do this by elimination. And I'm going to multiply this top equation by negative 2. That'll cause my x's to cancel out. And when I do that, I end up with the 2x plus 4y equals 10. And then I end up with a negative 2x minus 4y equals negative 10. The left-hand side simplifies to 0. The right-hand side simplifies to 0. And there you go, 0 equals 0. When is that true? It's always true. So these have infinitely many solutions. They're the same line. I don't know if you noticed, but Sean Tarbuck's been pretty good at recognizing when two lines are the same thing. And he likes the red version better because he said he likes the smaller numbers better in class. I think he said that on Wednesday. So anyway, when you have that situation, Sean, the system is a consistent dependent system because the two equations, their lines, intersect everywhere. They're actually the same line. All right, that's it for that video. Mr. Lawrence signing off. Have a good night, everybody.